Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, we are going to make use of this theorem. So rather than looking at the series that we're trying to investigate, we would look at the absolute version of that series. Now, if the absolute version, if the absolute version converges, then the original thing that we're trying to investigate will also converge. So we are trying to determine if this will converge or if it will diverge. Rather than looking at this, we're going to look at the absolute version of that very same thing. So we're going to look at the absolute version of the very same thing. And that will be, well, this thing here is just going to be +2, -2, +2, -2. So when you look at the absolute version, this whole thing here will be the same as this. So this thing here is really this thing here. So if this thing here converges, then the original thing that we're trying to investigate, which is this thing up here, the original thing will also converge. So rather than looking at the original thing, we would look at the absolute version of it. So this is our absolute version. Now, if this converges, then this thing here will converge. Okay, so now it's just a matter of determining if this will converge or this will diverge. So now look at this as being a fraction. So look at this as being a fraction. So you've got the numerator divided by the denominator. If you remove something from the denominator, then this denominator here will be bigger than this denominator here. It's a bit like this. Let's say you've got 3/8. I'm going to remove something from the 8. Let's say I'm going to remove the 2's, so it becomes 6. Now this denominator here, which is this one here, will be smaller than this one here. Will be smaller because I've just removed an amount from the denominator. I've removed this n. So this will be bigger than this, making the whole thing here bigger than this thing here. Think about it. This thing here, the whole thing here would be bigger than this number here because you've made the denominator smaller. So this thing here will be bigger or equal to this thing here. So now rewrite this as 2 to the power of n times 2. That's like this, 1, n+1, n+1. So now looking at this, rewrite this as to the power of n, and then you've got 2 here, so that's times 2. So what we've got here is this thing here is this thing here, and then now we've got well, if you look at this, if we sum the whole thing up, this 2 here is a constant, we can take it out. That would then become this, and then now this thing here will be this thing. So basically, from here, that will then take us to here. So now you're supposed to recognize that this is a geometric series where the common ratio is less than 1. If the common ratio is less than 1, then it's going to converge. We've done this many times, and you should by now recognize that if this is less than 1, it's going to converge. So in this case, this thing's going to converge. If something converges and then you times 2, the whole thing here will converge. So therefore, this being bigger or equal to this must also converge. Okay, so what we've done so far is that we've looked at the absolute version. We've looked at this absolute version here. That's this thing here, and we've just established that this thing's going to converge. We've just established that this thing is going to converge. Therefore, the theorem says that the original series that we're trying to investigate will also converge, meaning this thing here will also converge. So this series will converge. Okay.